Good morning. This is Professor Shannon Gracie from Miracosta College. We are working out of Robert Blitzer's Introductory and Intermediate Algebra for College Students text. And today we will be beginning rational expressions and their simplification. So for our beginning algebra class, we just have 3 more sections and then you're all done. So here we go. Today we'll be finding numbers for which a rational expression is undefined, simplifying rational expressions, and solving applied problems involving rational expressions. So let's go. We're going to warm up by factoring these 2 problems. So why don't you go ahead, or actually the first one is factoring, and then the second one I believe is solving. So pause the movie and warm it up. Okay, let's see how you did. For our warm-up to factor, if you notice, we have 1, 2, 3, 4 terms. There is no GCF for all 4 terms, so we're going to factor by grouping. So this will be equivalent to, I can factor out an x squared from the blue or red group, and I'm left with x minus 8, and then if I factor out a positive 2 from the blue group, I'm left with x minus 8. So I have a common binomial factor of x minus 8, and this was the results of the red group, and this was the results of the blue group. So our final result will be x minus 8, the common binomial factor, times x squared plus 2. How'd you do? Awesome! I knew you could do it. Okay, next up, solving. So what do we check for? Good, we check to see that there is a 0 on one side, and there is. So then we can go through and use our mad factoring skills. So we can use that 0 product principle. So our overall product is negative 20, and I got that from the 2 times the negative 10. And then we have a middle term that'll be the result of a difference of negative 1. And the 2 numbers that fit the bill, I believe, are negative 5 and positive 4. So here we go. This will give us 2x squared minus 5x's plus 4x's minus 10. Now keep equating it to 0. You want to have nice organized work. The way we split up the negative x is the negative 5x plus 4x. And now we can use our factoring by grouping skills for the next step. So I can factor out an x from the red group, and I'm left with 2x minus 5. I can factor out a positive 2 from the blue group, and I'm left with 2x minus 5, and that's all equal to 0. This was the result of the red, and this was the result of the blue, and lo and behold, we have a common binomial factor of 2x minus 5. I'll come up here so we have some room to work. So, factoring out the 2x minus 5, we're left with x plus 2, and that's all equal to 0. Now we can use our 0 product principle. So 2x minus 5 is 0, or x plus 2 is 0. 2x is 5, and then dividing by 2, we get x is 5 halves, or x is negative 2. So our end result is negative 2 and 5 halves. Those are the only 2 numbers that will satisfy the equation. All right, now that we are all warmed up, let's look at the first topic. Now the first topic is we are dealing with fractions. Remember, rational, you've got a fraction. Now this fraction happens to be made up of an algebraic expression over an algebraic expression. So therefore, we never want the denominator to have a value of 0. So we exclude numbers for which, or that yield, a 0 denominator. All right, so here we go. A rational expression. Oops, let's get our blue. Blue makes me happy. So a rational expression is the quotient of two polynomials. Rational expressions indicate division, and division by 0 is undefined. This means that we must exclude any value or values of the variable that make a denominator 0 Okay, so here we go. Let's look at some examples. And we're going to be using our problem-solving skills. And what you need to understand is what reason we are doing this for. All right, so for example, 5 divided by x. So what number would make, this is an undefined rational expression? What do you think? What is not okay in the denominator? Good, this one's pretty easy because it just has x. So x equals 0 makes 5 over x undefined. So we would exclude 0 as a number that could be plugged in for x. Okay, now b, we got to put a little more thought into it because it's not just x alone. We have the quantity x minus 4. So we'll use our problem-solving skills. We will set x minus 4 equal to 0 because we want to know what number makes a 0 denominator. So, adding 4 to both sides, we will get x is equal to 4. So, what have we found out? We have found out the number to exclude. So let's just write it out. X equals 4 makes x plus 1 divided by x minus 4 undefined. All right. Now, why don't you go ahead and pause the movie and try C and D. See how you do. All right. Let's see how you did. We have now the denominator is, so for this one we will set x squared plus 3x minus 28 equal to 0. So factoring, I'm going to go ahead and use trial and error on this one. If you need to use your factoring by grouping, please go ahead. Two numbers that have a difference of positive 3 and a product of negative 28 will be, we'll have a positive 7 and a negative 4. So then using the zero product principle, we will set x plus 7 equal to 0, or x minus 4 is equal to 0. And then isolating the x, we get x is negative 7 or x is 4. So let's answer the question. X equal to negative 7 or 4 makes 8x minus 40 over x squared plus 3x minus 28 undefined. All right. And finally here, if we set x squared plus 4 equal to 0. Now, is there such thing as a formula for the sum of two squares? No, there is not. Okay, heck no. So, here, this guy, think about it. If you square a number, do you get a positive or a negative? Good, you get a positive. And then you're increasing a positive number by 4. This will x squared plus 4 will never be 0. 0. So what does that mean? That means that there is no value of x which makes x minus 12 over x squared plus 4 undefined. All right. So there's the start of it. So now we're going to focus on simplifying rational expressions. So a rational expression is simplified if its numerator, and denominator have no common factors other than 1 or negative 1. So here we go. If P, Q, and R are polynomials, and Q and R are not 0, then P times R over Q times R gives us a result of, notice here we could divide out an R, right? And we would get a result of P over Q. Okay? So, here's some steps for simplifying rational expressions. First off, starts with an F. It's not a bad word. Good. Factor the numerator and the denominator completely. Then we divide both the numerator and the denominator by any common factors. Okay? Okay, so let's start off with part A. Well, we have a monomial in the denominator. So now here you have to be careful because you've seen problems like this before in chapter 5, but the instruction was for you to divide. Okay? So here we want to end up with one fraction, one happy fraction that's been simplified. Okay? So to do this, we need to factor. So we can factor out of 4, and we're left with x minus 16. So this guy factors to be this. We're going to be going a little faster with the factoring. If you ever need to pause the movie and, or replay it, please do so. Now, this is over 16x. Are there any common factors? Well, 4 goes into itself once and into 16 4 times. So at the end of the day, we will get x minus 16 over 4x. Now that is the answer because it is completely simplified. We do not have any common factors in these, the numerator and the denominator. Okay. Next up, part B. And at any time, if you want to pause the movie and try these on your own, I highly recommend it. Okay. So part B will factor out a 6 from the numerator. Whoops, and I just made up my own math right there. 6 times 3 is the 18. All right, and then we can factor out an 11 from the denominator, and we're left with y plus 3. So this is equivalent to this, and the denominator is equivalent to this. All right, so anything exactly the same in every way? Awesome, the y plus 3's completely divide out. And we end up simplifying this rational expression to be 6/11. Now be careful, that doesn't mean that y equals 6/11 at all. It means that this simplified so that there were no more variables. And we got a result of 6/11. Okay, part C. All right, so x squared minus 12x plus 36. Will factor to be x minus 6, the quantity squared. This is using the fact that x is being squared, 6 is being squared, 2 times 6 times x is 12x. Right? If you need to factor it the regular, the long way, please do so. And then the denominator I can pull out of 4, and I'm left with x minus 6 to the 1 power. So here, this guy was equivalent to this, and this guy was equivalent to this. So now I'm just going to go ahead and use law of exponents. This is going to be x minus 6 to the 2 minus 1 over 4. So here, this guy, remember, has a 1 power. So we have a common binomial base and we're dividing. So we will get x minus 6 to the 1 power over 4, which of course is just x minus 6 over 4. Okay. Part D. So we've got to do a little work on part D. We're going to have to factor by grouping. So here's our red group, and here's our blue group. So we can factor out an x squared from our red group, and we're left with x plus 4. And then our blue group, if we factor out a minus 3, we're left with x plus 4. That's all over x plus 4. So this was the result of the red, and this was the result of the blue. And lo and behold, we have a common factor of x plus 4. So we will get x plus 4 times x squared minus 3 all over x plus 4. Now, if you have an expression that's in a denominator, I mean, there's an implied parentheses around that. So you tell me, are there any parentheses that are exactly the same in every way? Good. X plus 4 goes into itself once. So this expression will simplify to be x squared minus 3. Okay, part E. What do you think about part E? Can we do anything? No. This is already simplified. Okay? Don't get crazy and start crossing out x's. There's no common factor. All right? You've got an x plus 5 in parens and an x minus 5 in parens. Is there any parentheses exactly the same in every way? No. All right? So it's already simplified. Now F has one of those difference of cubes problems. So x cubed minus 1 factors as x minus 1, and then we'll get x squared plus 1x plus 1. And then we have a difference of squares in the denominator. So we'll get x minus 1 times x plus 1. So here's our numerator. And here's our denominator. These are equivalent. So now we'll factor out, or not factor out, sorry, we'll divide out the common factor of x minus 1. And then we're all done. We'll have x squared plus x plus 1 over x plus 1. And don't forget, you're done. You weren't being asked to divide this expression. You were being asked to simplify this expression. Alrighty, next up. Simplifying rational expressions with opposite factors in the numerator and denominator. So here we go. The quotient of two polynomials that have opposite signs and are additive inverses is -1. So basically, one of the things you can look for is, are the ends the same except just switched, right? So here, x minus 3, 3 minus x, I mean, they're definitely additive inverses, right? So therefore, what we do is, you've got a choice, okay? You can either factor out a negative, or, you could think about this as multiplying the numerator and the denominator both by -1. I haven't changed anything, okay? Now the trick is, I'm only going to bring the -1, I am only going to multiply the -1 through using the distributive property, one of them. So I'm going to go ahead and keep the numerator the same, and then the denominator, I'll multiply it through. So this will give me -3 plus x. But look, if I commute, so this here is this. But if I commute the terms in the denominator, do you see that I'm going to get x minus 3? So now I can divide out the x minus 3's, and at the end of the day, it simplifies to be -1. Okay, alternate way to work a problem like this. In the first example, I multiplied by -1 over -1. An alternate way is to factor out a negative from either the numerator or denominator. So I'll factor it out from the denominator. So do you see if I factor out a negative, I'll get -3 plus x. So now here, these are equivalent. But what is that? That is going to be x minus 3 over the opposite of x minus 3. So then I can divide out the x minus 3's, and I still have that negative there, so I get a result of -1. So whatever you're most comfortable with, people typically prefer one or the other, so you're going to have to decide which way you like to do them. Okay, so why don't you guys pause the movie and try parts B and C, and then we've got an application, and then we'll be all done for this lesson. Okay, let's see how you did. I'll start down here. From the numerator, we can factor out a 3, and we'll be left with 3x minus 5. And now, from the denominator, I'm going to factor out a negative, and I'm going to be left with -5 plus 3x. So the numerator factored like so. And by the way, if you wanted to, it might have been a little more streamlined if you had factored out a -3 from the numerator instead of a +3. But that's okay. Either way will work. So this is going to be 3 times 3x minus 5 over negative quantity 3x minus 5. So dividing out the common factor of 3x minus 5, we get an end result of 3 over -1, which is -3. How'd you do on that one? Do okay? Good. All right, so now part C. X squared minus 4 factors as x plus 2 times x minus 2. We had a difference of squares situation. And then I see that x minus 2, and I see this 2 minus x. I'm going to factor out a negative. And you see we'll get -2 plus x when we do that. So this gives us a result of x plus 2 times x minus 2 all over the opposite of x minus 2. So when we divide out common factor of x minus 2, we are left with x plus 2 over -1, and that gives us a result of either the opposite of x plus 2. So if you put parentheses around, you can write it like that, or you could write it as distributed, -x minus 2. I would accept both results as answers on the final. All right. So on to our application. A company that manufactures small canoes has costs given by the equation C equals 20x plus 20,000 all over x, in which x is the number of canoes manufactured and C is the cost to manufacture each canoe. Find the cost per canoe when manufacturing 100 canoes. So we're evaluating C at x equal 100. So that'd be 20. So at x equal 100, we have C equals 20 times 100 plus 20,000 all over 100. So everywhere that we saw an X, we put in 100. Simplifying, we'll have C equals 22,000 divided by 100. So C is equal to 220. So we'll answer when manufacturing $100 canoes, the cost is $220 per canoe. Alright, so let's check out what happens when manufacturing 10,000 canoes. So, at X equal to 10,000, C is equal to, we're using the same initial formula, 20 times 10,000 plus 20,000 all over, sorry, a little shaky there, all over 10,000. So this is what I plugged in for X. And we'll get C is equal to, so 20 times 10,000 is 100,000. So we'll get 120,000 oh, wait a minute. Let me double check my math there. That's going to be a 2 with 1, 2, 3, 4, 5 zeros. So 20,000. So we'll get 22,000. Sorry. Divided by, I still think my numbers are off. Oh, because that was 20,000. I apologize, guys. This is going to be, I'll just write it out. How about that? A 2 with 1, 2, 3, 4, 5 zeros plus a 2 with 1, 2, 3, 4 zeros over 10,000. So that is good, 200,000. So we'll get 220,000 divided by 10,000, which gives us a result of 22. So it goes down dramatically, right? When manufacturing $10,000 canoes, the cost is $22 per canoe. And then, as more canoes are manufactured, the cost decreases. All right, so have a fabulous day, and I'm sure you'll be hearing from me later.